At first glance, amplitude modulation seems like an archaic choice for modern aviation, especially given frequency modulation's superior noise immunity. However, the aviation industry sticks to AM in the VHF airband, that is 118 to 137 MHz, primarily due to a critical safety feature regarding how it handles overlapping transmissions, defeating the FM capture effect. The single most important reason airband uses AM is to avoid the capture effect inherent to FM receivers. In an FM system, if two signals are broadcast on the same frequency simultaneously, the receiver captures the stronger signal, usually the closer one, and completely demodulates it while suppressing the weaker signal into the noise flow. If a pilot makes a routine position report and another pilot transmits a weak mayday at the exact same moment, the air traffic controller would only hear the routine call, entirely unaware of the emergency. AM signals are additive. If two AM stations transmit simultaneously, both signals reach the receiver's envelope detector. Their RF carriers will heterodyne, producing a loud squeal or beat note equal to the difference in their carrier frequencies. Even if the underlying audio is garbled, the ATC instantly knows two aircraft are stepping on each other and can ask them to repeat. In many cases, a trained ear can still pick out both voices through the heterodyne, just as the amateur radio net control picks call signs in a pileup. Graceful degradation at the fringe. AM and FM behave differently at the extreme edges of line of sight propagation, where the signal to noise ratio is exceptionally poor. FM threshold effect. FM maintains crystal clear audio until the signal strength drops below a specific threshold. Once it crosses that line, the signal drops off a cliff into heavy static, often cutting out abruptly. AM degrades linearly and gracefully. An AM signal will get noisier as distance increases, but the human voice can often still be deciphered by a trained ear deep into the noise flow. This predictable degradation is vital for aircraft operating at the absolute fringe of a ground station's range. Immunity to Doppler shift. Aircraft travel at high speeds relative to ground stations and other aircraft. While the Doppler shift at VHF frequency is relatively small, typically a few dozen hertz at Mach 1, it is still a factor in high-speed aviation. Since FM encodes audio intelligence directly into the frequency deviation of the carrier, Doppler shift can push the signal slightly off-center in the receiver's discriminator, potentially causing audio distortion or squelch gating issues in narrowband FM. AM encodes audio strictly in the amplitude of the envelope. A basic AM receiver is largely unaffected by minor shifts in the carrier frequency, ensuring reliable audio recovery regardless of velocity. Global interoperability. Aviation is a globally standardized industry requiring absolute interoperability. A plane departing Tokyo must be able to communicate flawlessly with a tower in London. Transitioning away from AM voice would require a simultaneous worldwide upgrade of every commercial airliner, general aviation aircraft, ATC ground station, and emergency backup radio. Instead of replacing AM voice with FM or digital voice, the industry has retained AM for time-critical tactical communications while offloading routine traffic like altitude clearances to digital text-based systems like Controller Pilot Data Link Communications (CPDLC).